So we are learning a little bit about the math class, just doing a few methods. There are a ton of methods that you can use, but in this class, we need to stick with just three basic ones and learn how to do the other stuff yourself for the most part. Okay, so we are learning a little bit about the math class. So to do that, I created a few variables here. In num1 and num2 are both integers, one negative, one positive. And we have a double here that's num3. And so the first math method that we're going to use is absolute value. So when we're doing any of these methods, we always begin them with the word math. So math is the name of the class. Math is a static class. And that just means that you don't need an object. So I don't need to create an object to run it. And I'm just using these words more often just so you can hear them and kind of get them assimilated into your brain. I realize maybe you don't understand what an object is or what static is just yet, but I'll go back and I'll say, remember the math class was a static class, and that's why we could just say the name of the class is math. So I start the name of the method with that name. So that's just really what it means to you at this moment, meaning I have to begin all of these with the word math, capital letter M. Okay, so ABS is the absolute value function, and simply if I want to do the absolute value, you can do the absolute value of anything. You can do an absolute value of a positive integer, which would make no sense because it's just the absolute value. But in programming, if you have, and you're not sure if it's an absolute, if it's a positive number, like someone entered it, you may want to make it an absolute value just so you can run it in a formula or something like that. So we might want, so you can put a positive number in there. So I put num2 is just 3. So that's perfectly fine. Does not have an issue with that. I could just put a number in there, and you can also put a negative number in there. So num1 is a negative number. You could also do some math. So it would do, this is a calculation, so it's going to do num1 plus 5. So this would be negative 25 plus 5. It'll do that first. It does order of operations first. So then this would be negative 20, and then it takes the absolute value of that and then runs it. Now notice that both of those numbers were integers, and the result is also an integer. And you know it's an integer from the output because there's no decimal point after it. If it was a double, it would output 0.0, even if there was no decimal part to it. So using that, I can also put a double in here, so you can put a double variable or a double number. So I'll just put a variable. So num3 was our double, and you know that it will come back out as a double. So this one's output, so let me just put here, this one's output was what, 20? And this one's output should be 6.84. Just as a reminder, I'll hopefully PDF these and give these to you. I don't need to do that, go away. There we go. Okay, there we go. So then we have exponents. So we can't do the little caret thing. That's not allowed. So what we need to do is we need to use the math class POW. So POW has two parameters to it. So what goes inside the parentheses here are called parameters. The first one is always the base, and the second one is always the exponent. There's no real criteria for the base or the exponent, positive, negative, decimals. They should all be okay to use. So that's all that we do. So say I want to do num1 to the third power. So that's to the num2 power. So you could put variables in here. I could also do a calculation inside here. So I want to do, it would do this. Num2 is 3. See, it's 3 up here. 3 minus 1 is 2, so it'll figure out that this is 2 and then run it. So I'm just trying to get across here that order of operations are always followed. It's going to do what's in the innermost parentheses first, then work its way out, just normal order of operations always. And of course, I'm sure I missed some sort of parenthesis. I always do. Whatever. So I just want this. Yeah, I missed a parenthesis. Okay, so we raise this to the third power. Oh, POW, thank you. So make that error. I forgot the POW. I'm so smart. All right, and so then it's a negative 25 to the third power. If I did keep that -1 here, it would be positive because, we know how to do math here. So 625. Now notice the result is always a decimal. It does return a double always. It's important to remember those things as we go. This next one is square root. So even though you could make this a fractional exponent, like a half is the same as a square root, you can also use the square root method. It might just be easier because it's simply just math.sqrt. And you have to have one number inside here, and please make sure it is a positive number. So it does have to be a positive number. It will give you an error if you don't put that in. So math.sqrt. You can do math in here too. It doesn't make any difference. So let's just do 11. No, let's do 4 because it's fun. Of course, I forgot a parenthesis. That is my nemesis, the parentheses. So you can put variables in there, calculations in there. It's all the same. So, sorry, that's the next one. So 2.0, notice it does always return a decimal. Also, if you do try to put something negative in there, it won't tell you right away, but it will give you an NaN, not a number error, meaning it's basically it's an imaginary number. So just be careful of that. So oftentimes, if someone is inputting a value, so let's say they input num3, and num3 is a negative number to us, and we just don't want to change it, or we need to check things, we could combine all these together, and again, it'll do it from the inside. So positive or negative number here, it'll do the absolute value of it. So then when it does the square root, it's going to be okay. So sometimes we do like to fail safe our programs to make sure everything that we put in is positive if there was a problem there, if there could be a problem there. So the next thing we're talking about is the maximum possible value of an integer. Now you'll notice this is an integer with an I. This is what we call a wrapper class. Not, whatever, any of the wrappers out there, whatever. It begins with a capital I. It is a class, but we can use it right now same as an int. It's to us right now, it's the same as an int. We just actually have to write that. So you saw that this is the maximum value here. So the maximum value for any integer is 2 to the power of 31 and then -1. So that is that 2 billion number right there. And that's that. So I think we kind of went over that already in the other one. So if you do try to put a number in that is bigger than that, so notice this is exactly 1 bigger than this number. So this is the max number here that an integer can store. It will give me an error here. You can see it's come up already. And that is what we call an overflow error. So integer number too large. So this is considered an overflow error. So just be careful of those. We don't want to get too big with these numbers. Now, what I wanted to show you is that if I do take this maximum integer value, which is this number right here, and I add 1 to it. Now, in essence, it's the same number as this. Okay. However, it is not an error. And actually, what appears is pretty nifty. It actually gives you this number here, which is actually the minimum value. So I just want to show you all that together. So I ran that. And you can see that This number right here was my max value. I added 1 to it. So what I output here is this number, which is exactly the same as the minimum value for an integer. Weird, right? Okay, that's what I like to call the max goof part. I don't know what they actually call it in real life. Okay. Basically, the idea is you have a certain number of digits that the computer is allowed to store, and it is allowed to store up to this grandiose number right there. So up to that 2 billion and whatever 8. Now, the problem is they take one of those numbers away. That's why it's 2 to the 31st power minus 1. They take one of those numbers away to keep track of the negative sign. So when we get to the, when you're on the negative side. So what actually happens is when you add 1 to here, it's actually thinking that you're putting a negative on it and adding 1 to it. So it's actually giving you that negative value. It's cool. It's just an interesting thing. Just be aware of that. Next, we have this, and we discussed this already a little with one of the classes, is 1e to the 6 e6. It's the same as your calculator. When you do compile this, it is simply scientific notation, and it does actually do the math for you. So here, so 1e6 is simply scientific notation. And it's 1 times 10 to the 6th power. So this one here is actually 1 times 10 to the negative 2 power. So that's why these two values, this is 6 zeros here, and this one here is, moves over 2 decimal places there to make it 1/100th. Okay. Last thing I want to show you is the precision, the lack of precision sometimes that we have. And with lack of precision, when we run this, I have this extra comment here. When I put something like this in here, notice if you count this out, I think there's 16 or 17 decimal places. So when I compile it and run it, notice that it only has 1. So even though num3 is a double, that's not an issue. I put this number in, but this is the number that it actually output, this one right here. So the problem with that is decimals only have approximately 15 decimals of precision. I think I spelled that word right. So it's decimal places of precision. So that's going to cause us issues when we actually do math, because anything else is cut off. And we'll discuss this when we start actually performing calculations and so on. And it causes a problem when we're comparing and we're doing math with doubles, and the computer takes this number, converts it to binary, and then does the math on it and converts it back, and it makes a precision error. So we will discuss that in the future. So this is just the beginning of that piece. So I hope you had an interesting time. Have a wonderful day.